Well, hey everybody. So, welcome to what we consider geometry. I know you're all ready to go. So, with no further ado, well, maybe there is, because first I have to ask you a couple of questions. Very important questions. So, first off, who invented the round table? Circumference. Get it? Good. And second, why does no one talk to a circle? Because there's no point. Alright, now that we're off to a good start here. Now, if you haven't noticed, this is my wonderful abode here. Just getting a little bored here in the summer, so I thought I'd kick back and with my little A&W here and make a video. So, first make sure, remember, the pause button is your friend. How to identify? Name, draw, and apply facts about points, lines, segments, rays, and planes. 1-1 is there's going to be a lot of vocabulary. So please make sure that you get it all down because that's going to be the essence to geometry, is making sure that you know all this vocabulary. And the most basic figures in geometry are undefined terms, which cannot be defined by using other figures. The undefined terms point, line, plane are the building blocks. Not too important to write down. Point. Probably want to get this down, especially how to name it and what the diagram looks like. Well, it names the location, has no size, it is represented by a dot. Not bad. A line is a straight path that has no thickness and extends on forever. Yes, indeed, I do mean forever. These are signified by either one lowercase letter or, more common, two uppercase letters with a line above with the two arrows on each side. Doesn't matter if it's XY or YX. Notice on the right what the diagram looks like. And plane. A plane is a flat surface, has no thickness, and extends forever. So this is signified by a parallelogram there, but obviously if it goes on forever, we cannot draw that. It's named by a script letter, R, that you see on to the right there, or plane ABC, 3 points that are not collinear. Collinear means they are all on the same line. Remember, pause is your friend, because I'm going to move on. Points that lie in the same line are collinear, like I had mentioned. K, L, M are collinear, K, L, and N are not. Points that lie in the same plane are coplanar, not complanar, because we will have none of that. Maybe we will. I may be one of them. Otherwise, they are non-coplanar. Name 4 coplanar points, meaning they lie on the same plane. If you had said, I'll give you a little bit of time, name your 4. Okay. A, B, C, D, they're all on the same plane. Name 3 lines then. So this is geometry. Part of the course is going to help you to see three-dimensionally, because not always is it easy. Excuse me. It's refreshing. It's my weakness. Root beer. Possible answers: line AE, line BE, and line CE. DE was the only other one that could have been. CB is not, because they do not extend forever. You'll learn that is a line segment. Use the diagram to name 2 planes. 2 planes? Well, we could call that plane R, or we could say another plane would be plane ABC. There we go. Boom. A segment, or a line segment, is the part of a line consistent of 2 points and all planes between them. Notice a way to name it: segment AB, with just a segment above, no arrows and no points. That's the same segment is segment BA, Bad apple. Diagram? Whoops, sorry. This is AB. Endpoint is a point at one end of a segment or the starting point of a ray. Capital letter CD. There is endpoint CD. Not the part in between, but just the endpoints are C and D. A ray is a part of a line that starts at an endpoint, extends forever only in one direction. Think a sun ray starts at the sun, extends forever in one direction. Its endpoint and any other point on the ray. So this one, order does matter, because ray RS would be different than ray SR. RS, this one, RS going this way. Opposite rays are two rays that have a common endpoint and form a line. The common endpoint in each and any other point on each ray. So EF would be starting in the middle, going to the left. EG starting in the middle, going to the right. Always with a ray, we always name it just with the arrow going to the right. Doesn't matter which way it is going on the diagram. Draw and label each of the following. A segment with endpoints M and N. Shouldn't be too hard. It looks like that. Opposite rays with a common endpoint T. So opposite rays, going opposite directions. Common endpoint has T, so the T has to be in the middle. Draw and label a ray with endpoint M that contains N. Label a ray with endpoint M contains N. So you should try some of these, so then you know. Do you know what you're doing? Or do you not? M contains N, so that means N can be anywhere on there. Bum, bum. Remember, pause is your friend. How many lines can be created through 2 points? How many lines can be created through? If you just have 2 points, how many lines can you create? Can you define a plane, not plan, but 3 collinear points? So can you say any 3 collinear points, can that be a plane? If 2 points lie in a plane, then a line containing those 2 points, blank, 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 and blank. Let me go back. Answer to the first one, how many lines can be created through 2 points? That answer is 1. Can you define a plane by 3 collinear points? That answer is no. They have to be non-collinear. If they're collinear, they will all be in a spot, and that plane can rotate, and it'll be multiple different planes then. If 2 points lie in a plane, then the line containing those 2 points lies in the plane. That's kind of simple and basic. So if the 2 points are in the plane, then the line that has those 2 points is also in the plane. A postulate, I'll call it the postulate most often, but another word for it is axiom, is a statement that is accepted as true without proving it. Many things in geometry we will have to prove, but a postulate is not one of them. Whew. In our class, we'll call postulates the moments. Obviously not a geometry term, but postulates are sometimes one of those things where you're like, really, Ras? Do you really have to teach me that? And yes, I do. But they are kind of like a duh. Something that just makes sense. Points, lines, and planes. And this is what I had gotten at before. Through any 2 points, there's exactly 1 line. Because remember, you can't curve it, because then it's not a line. You do not have to know these numbers either. I'm not going to test you on numbers. That's just silly. Through any 3 non-collinear points, there's exactly 1 plane containing them. If 2 points lie in a plane, then the plane containing those points lies in the plane. Name a plane that contains 3 non-collinear points. So you could say plane R, or you could say plane GHF. Well, I said them in the same order too. This is just a little bit of background. You don't need to write this down. A set of two or more equations containing two or more of the same variables is a system of equations. You learn to solve these through elimination, substitution, or graphing. What does the solution represent then? The solution is where the graphs of the equations intersect at a point then, if you used it by graphing. So where the two graphs intersect is where the solution is at. A geometry intersection then, an intersection is the set of all points that two or more figures have in common. The next two postulates describes intersections involving lines and planes. But first, I got a nice little video here. What is formed when two lines intersect? So two lines, here in my video here, there's like a line, there's technically a line, but same thing with line segments as well. And what is formed there? Well, I would consider that to be a point. What is formed when two planes intersect? And we'll get to show that. This is in my house, by the way. I know, pretty exciting. But right there, try not to get you dizzy there. There's the wall, there's the ceiling, so you can view those as planes. Now where those intersect, what is formed right there? If you said line, you are correct. Now let's go one step further. It's going to bring you to right there. One plane, two plane, because that's the two walls. Once again, that's form a line right there. But then we bring in the third plane, and that they all meet right there. So all of those three can meet at a point. And then here's the actual postulates. Two lines intersect, they meet at a point. Two planes intersect, they intersect in exactly one line. Okay, now it's a different thing. We are now drawing some of these examples. Use a dashed line to show hidden parts. A dashed line will indicate the part of the figure is not seen. Sketch two lines intersecting at exactly one point. Not bad. Boom, boom, intersect at a point. Sketch a figure that shows a line that lies in a plane. Okay, so then your plane is a parallelogram. There's your line. Not bad. Sketch a figure that shows two lines intersecting in one point in a plane, but only one of the lines lies in the plane. Two lines intersect at one point in the plane, one lies in the plane though, not the other. And there we go. There's your parallelogram. One line lies in the plane, the other one's just intersecting right there, so that one's technically kind of going through it. Excuse me. Yummy. And now, no, I've not paid by A&W either. I wish. But technically, since that plane goes on forever, we can't just draw that forever, but that's why it continues to be dotted underneath there, because technically we really still can't see that. That's why it's continued to be dotted. And that finishes off the show for today. Thanks, and we'll see you tomorrow. Or maybe later today, depending on when you watch this. Hopefully, you watched at a good time, though. Have a good day. Signing off.